you have matrices like, if I want an identity matrix, I can use just I3. This will give me a 3 by 3 identity matrix. Okay. This will be a 3 by 3. If you give it as 2, you'll get a 2 by 2 and so on. Okay. I means an identity matrix of that particular square order. You can also have, similarly, just going to clear the screen. You can also have ones. In this case, if I just give 3, it means a matrix of ones like this, or I can give 3 comma 4 and then I'll get this. So if it's one parameter, it will assume it to be a square matrix, and if it's not, then you can give rows comma columns and you'll get that. We'll be using all these when we go ahead, so I just want to give you an idea. Okay, same applies to zeros. Sometimes you will need a null matrix, especially when you're adding stuff and you get zeros like that, or I can give. Alright, so if you give one parameter, it will assume it to be a square matrix. If you have multiple parameters, then it is obviously a non-square matrix with whatever dimensions you give it. Okay, now
I tried to do twos. Twos doesn't work.
there's only ones and zeros. There's no twos. Okay. All right. Now there is one more thing that I want to show you, which is, so this is a matrix. If you add the rows or the columns, they'll come up with the same sum. So in this case, if you add them like this or like this, any row or column will give you the same thing. Okay, so you can have a 4 by 4 matrix like that with a constant sum. Okay, so the sum of any row or any column is going to be the same. Now here, I want to explain one thing here. Let me use this command for 1 second. Just give me 1 second, I'll bring this up again. All right, let's say I want to, for example, I want to isolate this column, right? I just want all elements of this column. So what I'll say is column 1 will be equal to D of all rows comma 1. Okay, this means all rows. When I do 2 dots, it means all rows. So it will include 1, 2, 3, 4, 5. That means all rows. Let's say I want only 1, 2, 3. Only rows 1, 2, 3. Then I can do this. Alright. This will tell it only rows 1, 2, 3. If I just use the 2 dots, that means it means all the rows in that matrix. Alright. So in this case, when I use 2 dots, it means all the rows. I don't have to specify the row numbers. It will take all the rows in the first column. Okay. When I do 1, 3, it means from only 1 to 3. The same applies to, instead of doing columns, I can do row, in which case I'll switch this over. I can say the third row, all columns, and then I'll have this. Okay, and then obviously you can transpose it the way you like. All right. So let's go ahead and we'll write a script. A script is it's like a function. Okay, so you can call it to generate anything that you want repetitively. So let's start with that. The first thing that I'm going to do is let's clear the memory. So I'll just say clear all. Okay, this will erase my memory, and I'm going to go to the script here. Okay, so because whenever you write a script, what we have to do is we have to define a keyword, which is function. Okay, we'll start off with the word function. Function, and this is returning a value R. Okay, the function returns a rotation matrix, R 3 by 3 matrix R. So we'll say this will be rotate, ROT, within brackets, axis, comma, angle. This is the functional prototype. It will accept the axis that you want to rotate by, because we want to do it like, we want to use the same notation. R, X, theta, okay? So axis, angle. Now there is one issue we have here, that the angle usually when you talk about angles, I'm just going to say N here, when we talk about angles, you can, let's go for 1 second, let's go to the command window here. Okay, let's go to the command window. When I say cos 45, right? Okay, right? So the reason it gives me this value is because, or let's say cos 90, should be 0. The reason it gives that is by definition MATLAB takes it in radians, it does not take it in degrees. So we have to be careful when you use cos. If you want to use degrees, then use cos d. So this tells cos d is in degrees. Okay, if you just use cos, it's in radians. So what we'll do is we'll try to stick with radians. So when I go to my script,
Probably open the script.
just minimize this. You'll have 2 windows here.
Oh, okay.
Okay, if not, then you can just dock this within it, dock the editor, and you can have it within here. Okay, so if you want, you can do that. And this will run independently, it does not disturb your script, so I can erase that. So what you can do is we can comment here. This will, when you use the ampersand, the percentage sign, it will be angle in radians. Okay. Now, what I want to do is I want to set up that function like this. So if I give rotate x comma pi by 2, I should get a matrix, right? So I want to use this functional notation. This will be my axis, and this will be this. Okay, so what we'll do is we'll say here, I'm just going to say if axis is equals to x, all right? If axis is equals to x, we'll set up the angles here. We'll do this. So we'll say C is equals to cos of angle, okay? And S is equals to sine of the angle. All right? So that we don't have to keep on calculating this over and over and over again. Okay? Now we can say here R or rotation matrix will be equal to the first row. In the case of X will be 1, 0, 0, semicolon, right? Zero, cos, right? Minus sine, 0, sine, cos. Okay. And we'll test this out and then we'll add the other 2 axes. Okay?
Why do you have 2 ends for it and for the function?
Yeah. All right. Keywords, whenever you use a certain keywords, they will be highlighted, or control words will be highlighted in blue. Now, one thing, be very careful with one thing, which is, I hope there is no other command called rotate. So I'm just going to say help rotate here, just to make sure there is no other command called rotate. There is no command called rotate, which is good. So we can save this. Please save it. Whenever you save a function or a function, you have to save it by the name of the function. Otherwise, when you call it, the compiler or the MATLAB does not know where to find it if you save it by any other name. So let's save this as ROT. It will automatically pop up as ROT when you try to save this. Did I save it? Yeah. So this is here. When you save it, you should see the name right here in the blue tab, matlab/rot.m. So now I can try to call this here. Let's go here, ROT. I'm going to say A, rotation matrix A is equals to ROT x comma pi. Let's see. Or maybe I have to use the semicolon. Okay. So what we'll do is, all right, because this is a character. Otherwise, if you just write it like this, it will assume it to be a variable. Pi is a reserved word, which means the pi, which is 22/7, or 3.14 radians. So you'll mention your axis like this to make sure that this is a character, not a variable, and then you can give the angle like that. Okay.
Zero.
I'm sorry?
Negative 0.
Angle of 0?
Negative 0. That.
That's not negative 0. It means that it's not resolved to this. If it's 0, it will be directly 0. If it's 0.000 something, then it will come up to this resolution. Okay. All right, let's add the other two axes. Else if axis is equal to 1. And then you'll have to add one more for z. Yeah.
So you got a problem with the rotate.
You got a problem with what?
Rotate.
Why are you using the double promotion? There's a single apostrophe. Where is the double? Why are you saving this on this? Save it in the current folder. Where's the current? What's in the current folder? Save it in the
Thomas, can I create more than one function in script file, or does it have to be one?
You can create more than one so long as it is only used by the same function. If it's, see, when you call a script, right, it is called by the file name. So if you want a function that is only used locally by the same function, then you can have it within the program. But if you're going to use it independently, then you have to save it as a different file. All right, let's finish this so we can have. Okay, make sure you save this and test it out for all the, check it out for all the axes. So for example, if I want to rotate this by the angle, we already did x, y, by I want to do pi by 2, okay? Because we have to give the angle in radians, okay? Pi by 2, there is at least one end missing.
Professor, else if,
Is one word?
yeah,
Okay, let's save this. Yeah. All right, so I think we are good with this. Let's do pi by 4 for z. All right, so you have this angle. Now, what we'll do is, we'll try to test this. Now that the script is saved, you don't need the script. We can go to the command window and we can do whatever functions that we want to test out. So let's take an example. Let me give you the, can you bring me the handouts? Yeah, that starts on one of each. Give me the one and one of the both. Okay, so we can do fixed axis and current axis transformations. So it says find the composite rotation matrix for, first one is 45 degrees about fixed x-axis. Okay, then we have 90 about current z-axis. And 90 about current y-axis. Okay, so in this case, my R will be equal to, based on what we wrote, the first one is rotate, because even though it's fixed, this is the first axis, so it will be x, comma, pi by 4 times rotate z comma pi by 2 times rotate y comma pi by 2. Okay, so this is what you will write down in the case of writing the command. All right, so x, I don't know if this is clearly visible from back there. So what you'll do is you'll write this command line here based on what we did, and you'll write the eventual rotation matrix that you get in your worksheet. So what I'll do here is, here we will have R is equal to rotate the axis x by pi by 4 times rotate z with pi by 2 okay, so you'll get this rotation matrix. Now let me give you one question that I want you to think about once you go, because we have written a function. So you can continue with the worksheet, but I need your attention for 1 second. Okay. Same thing applies to doing Euler and the other angles. I want you to write a function after you finish this. It's not in the worksheet, but it will be a homework question. We know that when you have an arbitrary axis, r, k, theta, right? And then we express this in the terms of r, whether you want to do z rotation by alpha. Okay, let me draw this first. So you have this axis, and this is the vector k that you want to rotate by. K, when you impose it here, this is one angle alpha. When you go here, this is the angle beta, right? Now, a general rotation matrix that we did here, ROT, about a standard axis, is you give the axis here and the angle here, right? So it could be x, pi by 2, or whatever it is, right? But if I want to do this, an arbitrary axis, okay, then I want you to write a function, rotate. This axis is defined by, k is defined by only two angles, alpha and beta, right? So alpha, beta, and the rotation that you're trying to do, theta. Okay? This will be a homework question, which will be write a script to get a rotation matrix about any arbitrary axis k defined by the two angles alpha and beta, because k is defined by what angles it makes with the standard axis. So alpha, beta, and theta. This is all you need to construct a rotation matrix, right? Because how k is oriented in space is given by these two angles. Now you can express this as we did in class. R will be equal to, first you do a rotation, then you do rz theta, then you undo the rotation, right? So based on this, you'll use these functions. The script that we did today will be embedded within this, so that you can do z theta, okay, or other standard axis by alpha and beta. So just think about it. It's I'll take that when we meet in the next class, but that will be the homework question based on what we do today. All right, let's do the worksheet. If you run into any problems, just raise your hand. If you would like me to discuss any question, feel free. You have a problem? Okay, can you finish the whole command first? Okay. Well, there has to be two ends, right? There is only one end.
You have to write all four decimals.
No, that's good. 3 is one.
That's the answer for the first question.
This is the answer for the first question. But the next ones I want you to try them by your own. Whether they're fixed or you'll put the order of multiplication accordingly. Where did you save it? Yeah, it's not going to work. Save it in the same folder. If you put it on the desktop, it's not going to work. Save it in the current folder that you are. Start with the first one, right? And then whether if it's fixed, you go towards your left. If it's correct, you go towards your right. Yeah. Okay. No, the order of multiplication changes, right? If it's fixed, you multiply, that's what we did. If it's fixed, you multiply. If it's current, then you postpone. So you don't multiply all of them in this one. But if it's fixed axis, you multiply to your left. If it's current axis, you multiply. You start with the first one, and if it's a fixed, you multiply it here. You put the second one here. If it's current, you put this. Three multiplication, postpone. Go to the MATLAB folder and save it there.
So the first one is example same things do
we are going to multiply this by this. This one will be at the beginning, yeah?
Oh.
No, first one is this, right? First one is this, right? So this will be R, X, 60, right? Then it's fixed. So this will be here. Fixed to this side, so Z, 45. Okay? Then again fixed. So this will be exactly Y, 9, right? And then current, this way. R,
What's this 35 or 6?
yeah. I is 180, right? No, even if you, see, the problem is if you do it like this, even after doing this, you will check this again. If you do else if one is true, then it will just go to the end of it. Can you spell function correctly, please? Right? What I want to write is command would be this. The answer is the matrix you get. Right? Multiply it with that from yeah.
So, what would be the difference between fixed axis and
Yeah.
Should I read this?